What you see on your screen is an ellipse and its equation, that's x squared by 36 plus y squared by 9 equals 1. Now what we need to find here is the area bounded by this ellipse. That is the area of this shaded region. Look at this ellipse carefully. Do you notice that it is symmetrical? Yes. In fact, it is symmetrical about the x and y axis. So if we can calculate this area, that is the area of the ellipse lying in the first quadrant, then we can easily find the area of the entire ellipse. So the area of the ellipse is 4 times the area of the ellipse lying in the first quadrant. So what we need to find is this area, the area lying under the boundary of the ellipse. And how do we do that? We use the help of integration. So what's the formula? Let me show it to you. There. Let's say that y equals f of x is a curve. You see the curve, of course. Now the area lying under the curve, that is this area, from x equals a to x equals b, is given by this formula. We are talking about definite integrals here. Integral from a to b of y dx. That is integral from a to b of f of x dx. Y, of course, is f of x. So using this formula, we will calculate the area of the ellipse lying in the first quadrant. What was the equation of the ellipse? X squared by 36 plus y squared by 9 equals 1. In fact, we can also write it like this. You simplify this further and you finally get y equals 1 by 2 square root of 36 minus x squared. Now what is the area of AOB? That's integral from 0 to 6 of y dx. We already know that y equals 1 by 2 into square root of 36 minus x squared. So let's substitute. In fact, we can take the factor 1 by 2 outside the integral sign. So we do that. So what do we do? Now we integrate and what we get is this. Let's now plug in the lower and upper limits of the integration and you get 1 by 2 into 18 sine inverse 1. Sine inverse 1, that's pi by 2. So we get 1 by 2 into 18 into pi by 2 or simply 9 pi by 2. Now this is the area of the ellipse lying in the first quadrant. So what is the area of the ellipse? That's 4 times 9 pi by 2, that is 18 pi. So we now know that the area of the ellipse is 18 pi. And this is the method we follow to find the areas bounded by simple curves. There's only one important thing that you need to be careful about. That is to substitute the correct values of y and the limits of integration. Don't forget that.